Okay, here we go with our notes for today. So from our warm-up, we were looking for the area of a region between two curves. Now we're going to take that region between the two curves and we're going to rotate it. We're going to revolve it around either the x-axis or the y-axis. And same idea as we previously did for the volume of revolution. And you're going to sketch the graph to help you find the values for A and B. Okay, so just like in the warm-up, you needed to figure out where the two curves were crossing each other. Okay, we need to figure that out so we know what's going on, where we're integrating from. And if you're being asked to revolve around the y-axis, you got to make sure you rewrite your functions so that they're in x equals form instead of y equals form. Okay, so just watch out for that. If it is revolved around the y-axis. So this is an extra step. This step is extra. This is only if you're revolving around the y-axis. Okay. Then you're going to set up your integral by taking each of your functions and squaring them and then subtracting them. So don't try and subtract and then square. That doesn't work. Order of operations. You can't mix up squaring and subtraction. Okay, you got to do it in the right order. So square each function, then subtract it, then you can integrate. Okay, so we sketch it to figure out where are the intersections, and you might have to do some algebra to figure out where the intersections are, or use your graphing calculator, and then set up the integral and then solve the integral. Now remember, after you've set up your integral and you've simplified it, don't forget to multiply by pi at the end. Okay, I noticed that on the warm-up yesterday. Some people were forgetting to multiply by pi when they got to the last part. Okay, so don't forget that. It's easy to forget, so don't forget. You have to multiply by pi. All right, so let's do an example. Here's my example. I want the region bounded by the curves y equals x squared plus 6 and y equals 8x minus x squared is rotated 360 degrees around the x-axis. Find the volume of revolution. Okay, so I'm going to sketch this. See, what does this look like? So, y equals x squared plus 6. Well, that's an easy one. That's just going to be, I'm going to count by, I don't want to make this actually to scale. Let's count by threes. 3, 6. Okay, so that's going to be like this. It's going to be something like this. Okay, so there's the first one, y equals x squared plus 6. This one has a minus x squared, so this one's going to be upside down. And let's see, I could factor that. I'm going to say, let's see, 0 is equal to 8x minus x squared. So 0 is equal to x times 8 minus x. So my x-intercepts are going to be 0 and 8. So it's going to have 0 and it's going to have 8. So let's say 3, 6, whatever. Okay, and it's going to be upside down. So it's going to be something like this. Oh, so a little tiny region is going to be overlapping. Okay, so I'm going to have like something like this. I can double check that on my graphing calculator. So I'm going to go ahead and put that in. X squared plus 6. Make sure that I have my little sketch approximately right. 8x minus x squared. Graph it. Let's see what it looks like. Okay, yep, there's the first one. And where's the second one? Here it comes. Okay, my window isn't exactly right. So let's go, y needs to be a little bigger. There's the first curve. And there's the second curve. Yeah, okay, so it's just a skinny little thing where they're overlapping. Okay, I got kind of a rough idea of that. So I definitely need to find the points of intersection. So I need to know where are they crossing here and where are they crossing here. So let's see, if I just trace it on the calculator, does it give me nice points, or am I going to have to do it by hand to get exact values? So let's go ahead and I'm going to find the intersection. First curve, second curve, yes. Oh, look at that. The first one is at 1 and 7. So the x value here for this one is at 1. Yay. That was good. So I don't actually have to do the algebra for that since I was able to get, it gives me a nice exact answer on the calculator. If it hadn't, then I would have needed to set the two of them equal to each other. Okay, so I could have gone x squared plus 6 equals 8x minus x squared, and I could solve that. But right now it's giving me a really nice answer, so I'm not too worried about that. Okay, let's do it again. Intersection, option 5. And this time I want to move closer to the other intersection. Enter, enter, enter. And I get 3 and 15. Yay! Okay, this one, this is at 3. This intersection is at 3 and 15, so that's 3. So I could have solved this. I could have added x squared to both sides and gotten 2x squared minus the 8x minus 8x plus 6 equals 0. I could have factored that, factor out the 2, x squared minus 4x plus 3 equals 0, and then 2 gives me x minus 3, x minus 1, and I can solve that. I get x equals 3 and x equals 1. Okay, so there it is, doing it by hand. I actually did it on the calculator. Either way is fine. The calculator, though, is no good if it's not exact answers. Okay, if it doesn't give you integer answers, if it gives you some crazy looking decimal, then you got to do it by hand. Okay, and get an exact answer. All right, so we've found our points of intersection. This is not revolving around the y-axis, so I don't have to worry about that step 2. I don't have to worry about rewriting them in x equals form. Yay! Instead, I can go right to step 3, which is setting up my integral. So I'm going to set up my integral. It's going to be pi. Don't forget the pi. Volume equals pi times the integral. And it's going from x is 1 to x is 3. And we're going to have x squared plus 6 squared. Okay, we're going to square both of these. Oh, wait, sorry. The one that's on top is the one we want to do first. I almost forgot. The one that's on top is this one, So I want to put that one in first. 8x minus x squared, then minus the one that's on the bottom. If I do it the other way, it'll still work. It's just that I'll get a negative volume, and that'll be weird. And then you would just, once you have a negative volume, you would just change it to positive. Okay? So, but this way it'll come out with a positive answer. Okay, so right now we could actually do this on our graphing calculator, and that would be fine unless it gives us a decimal answer, and it's going to because we've got this times by pi. So on MathSpace today, it wants exact answers, but let's just see what happens if we put this in. So I'm going to go y equals. Let's clear this out. Let's just see what happens. So I'm going to have 8x minus x squared, close parentheses, squared again, minus, next parentheses, x squared plus 6, close parentheses, squared again. All right, what a big ugly mess. What the heck does that look like? Remember, it's not going to look like our sketch anymore. Okay, there it is. Yikes. All right, I think this is going to be a problem because some of this is going below, perhaps, 1, 2, 3. No, the part that we want is all above the x-axis, so I think we're going to be okay. So if I do second, calculate, and option 7, my lower limit was 1. My upper limit is 3. And it says it's 58.6666. Oh my gosh, look at that. I know how to write that in exact form. That would be 58 2/3. So all of this, it looks like I have pi times 58.666 repeating. That would be 2/3, 58 2/3. So now I could actually multiply that by pi. But what we're going to do, since we want an exact answer, we're going to go ahead and change this to an improper fraction. So let me get out of here. I'm going to do 3 times 58 plus 2 gives me 176. So this would be 176 pi over 3. So that is fair game. You could do that. You could put that in. If this was a problem in MathSpace, you could do it like that because we were able to put it into the graphing calculator and we were able to figure out the exact answer. Okay, what if it didn't give me such a nice fraction? What if it didn't give me such a nice fraction? And I think all the polynomial ones will give you nice fractions, but if it hadn't, you'd need to do this like yesterday's warm-up. You need to multiply these out, okay? So, or like yesterday's notes. We need to multiply it out. Okay, so here it is with the graphing display calculator. So this was with the GDC. We used our graphing display calculator to do it this way. Okay, if we were doing it by hand, it gets a little bit harder, okay, because we need to multiply this out. So by hand, we would have to do 8x minus x squared times 8x minus x squared. So we'd get 64x squared, and then this would be minus 16x cubed, right? Because I'd have minus 8x squared and then another minus 8x cubed, minus 8x cubed and another minus 8x cubed. And then negative x squared times negative x squared is positive x to the fourth. Okay, that's the first one. The second one, 1 to 3 times pi. The second one, we would have x squared plus 6 times x squared plus 6. That would give me x squared times x squared is x to the fourth. And then I'd have 6x squared plus 6x squared. That would give me 12x squared, and then plus 36. Okay, and then we are going to subtract these from here. Oh, this is nice. The x to the fourth minus x to the fourth goes away. Let's see, x squared, I have 64 minus 12, so that would leave me with 6 minus 1, 5, 52, right? So I would be left with 52x squared. Okay, so I did that one. I still have the minus 16x cubed, and then this becomes a minus 36. Okay, so I'm combining my like terms. And now I'm ready to integrate. Okay, sorry I left off the dx, but you get the idea, dx. Okay, now I can integrate it. So this one's going to become x to the third, 52 over 3, minus, this is going to become x to the fourth, 16 over 4, minus 36x, and that's going to be, 1 to 3. Evaluated from 1 to 3. And then times by pi. Okay, so here I would substitute in my 3 and my 1. I'm running out of room. I'd have to do this on the next page maybe. Okay, let me, let's see. Okay, let's go to the next page. So if I kept going, let me copy this over. I'm going to have pi 52 x cubed over 5 minus 16 x to the fourth over 4. You can tell I'm doing this live. No net. I did not do this ahead of time, so hopefully I haven't made any mistakes yet. All right, here we go. So now we're going to plug in the 3. So pi 52 times 3 cubed over 5 minus 16 times 3 to the fourth over 4 minus 36 times 3, all of that, minus, I should have written smaller, 52 times, 1, right, that's easy, okay, 52 times 1 cubed, but I'm going to write it out anyway, minus 16 times 1 to the fourth, over 4, minus 36 times 1. All right, I'm going to simplify the easy one first. So 1 cubed is 1, so this gets me 52 over 5 minus 16 over 4, which is just 4, minus 36. Okay, so that's this part. And then this part, I would actually grab my calculator. I would not do this by hand. Okay, so this one, I'm going to have 52 times 3 to the third is 1404 over 5, and then this one, 16 times 3 to the fourth. Oh, actually I could reduce that first. 16 divided by 4 is 4, so let's do that again. 4 times 3 to the fourth is 324, And then 36 times 3 is 108. Oh my gosh, my dogs are going crazy now. Oh, this is going to be great because these are going to be in fifths. Okay, so 324 and 108 is 432. Actually, I can go ahead and change this to a decimal because if it's a 5, I know that it's going to be a nice decimal. So 280.8. Uh-oh, I have a feeling I'm going to get the wrong answer. Minus 432 because we had 2 thirds before. This is not looking good. So that gives me negative 151.2. Oh no, this is starting to not look good. What did I mess up? Did I put the wrong exponent somewhere? Oh, that was a 3. I copied it over as a 3. This was a 5. This was a 3. That's why. Okay, I was thinking, how are we going to get 2 thirds out of this? There's no way. Okay, so there's where I messed up. This was over 3. This was over 3. Oh, but wait a minute. So this one's over 3. Over 3. That's what I did. Okay, good thing for that graphing calculator, so I know where I'm trying to head. Okay, 1404 divided by 3 is 468. Minus 432. 468 minus 432 is 36. So I've got pi times 36 minus, what have I got over here? 52? Oops, 52 divided by 3? Good, there's where I'm going to get my 2 thirds is going to end up happening. Okay, so that's, I still have 52 over 3 minus 40, yeah? So let's change this to thirds. And 3 times 40 is 120, so that would be 120 thirds. So 52 thirds minus 120 thirds. 52 minus 120 gives me 68, negative 68 thirds. Okay, so this whole thing is negative 68 thirds, but it's minus a negative, so that's going to become plus 68 thirds. Now I need to change my 36 to thirds, so 36 times 3 is 108, so this becomes 108 thirds plus 68 thirds times pi. 108 plus 68 is 176 over 3, and then times by pi. Did I get the same answer as I got with my GDC? Yes! Oh, hallelujah. All except for that transposing error where I couldn't read my 3. We get the same answer. All right, so that's the ridiculously long way of doing it. So when you're in math space, go ahead and try and do it this way first. Save yourself the problems. But if you can't get an exact answer off your graphing calculator, then you're going to have to do it the long way. All right, good luck. Just a few problems in math space today again, like yesterday. And there is a 10:30 Zoom meeting. Oh, I should have said that at the beginning. Zoom, 10:30 for those who want to ask questions or if you just want to come and say hi. All right, bye-bye.